Meredith McCune, and I'm going to be talking to you about Section 8, Topic 3 of Geometry, which is special right triangles. So to start it off, I'm going to explain a little bit about special right triangles. There are two special right triangles, and the triangles have special relationships in their ratios that exist among their other sides, so that's why they're special. And in the first one, there is a 45, 45, 90 degree special triangle. And in this triangle, the measurements of the angles are 45 degrees, and 90 degrees, which equals 180 degrees, which is there's 180 degrees in a triangle. And with this, the leg of the hypotenuse is the length of the leg 2 squared. So on an example of the 45, 45, 90 degree triangle, the length of this is the leg and this is the leg. That is the hypotenuse, but the x and the x is the x and the x are both equivalent, and then the length of the hypotenuse is the length of the leg squared, as you can see there. So with an example, we're going to solve this one, which you're looking for x and y. So here's x right there and here's y right there. So I'm going to tape it on the wall so we can work it out. Okay. So what you're first going to do is you're going to label the sides of the triangle as s and the hypotenuse as s times 2 squared. And you're going to do this because the sides are can also be known, or like x and y, you don't want to call them x and x squared by 2 because that can make it a little bit more confusing. So you're just going to call them s as sides. So right here, you're going to label side 1, you're going to label it s, and you're going to label side 2, you're going to label it s, and this one, the hypotenuse, you're going to label it s squared by 2. And right now, you can tell that s squared by 2 equals 6, equals 6. So what you're going to do is you're going to try to get s by itself to find out what the length is. So the way you're going to do this is you're going to subtract the square because you're trying to cancel it out, but whatever you do to one side, you have to do to the second side. So you're going to do the exact same thing to the second side right there. And so then it's going to leave you with s equals 6 over 2 squared. And with that, you are going to multiply across, because you can't have a fraction with a square root on the bottom. So you're going to multiply across to cancel the square root out of the bottom. So 2 squared times 2 squared equals 2. So you're going to get s equals 6 times 2 squared over 2. And right here, you can tell that these are the whole numbers, and you're just going to ignore that for now. So 6 divided by 2 is 3. So you're going to find that your s equals 3. Your s equals 3 times 2 squared. And you're going to find that your y, you can tell that y equals 6 meters right there, so you already know what your y value is. So let's check the answers, and you can tell that we got these right. So that is how you find it with a 45, 45, 90 degree triangle. And now with a 30, 60, 90 degree triangle, here's a little bit of information about it. It's the same thing as 45, 45, 90, except the angles are different, but it's still a right triangle. It's still special. You just have a different way of solving. So to the special relationship is the one length is going to be x. The length between the 90 degrees and 60 degrees is x. And the length between the 90 and 30 is x times the square root of 3. And the length of from 60 to 90, which is the hypotenuse, is double x. It's just x times 2. So now with an example, you're going to be solving for x and y. You can tell that the hypotenuse is 14. So first you're going to label, like we did on the other one, we're going to label it. So we're going to label the hypotenuse. The hypotenuse is going to be labeled 2x like that. And so what you're going to do is you're going to try to solve for x, first of all. So 2x, and then this is going to be considered x, or it can be considered s, because it's the length between the 90 and the 60. And the length between the 90 and the 30, you're going to call that s times the square root of 3. Or it can be x times the square root of 3, whichever you prefer. So with that, you're going to first solve this. You're going to divide it by 2, Whatever you do to one side, you have to do the other side. You're going to cross that, and it's going to be x equals 7. So you already know what this side is from that. So you're already found 1, the x equals 7. So now what you're going to do is you're going to plug in that x, or the s, which is 7, and you're going to plug that into this side like we just did on the other one, except instead of the square root of 2, it's the square root of 3, like this. So you're going to get it as 7 square root of 3. And now that's your final answer, because there's no other work you can do. There's nothing else that you can have, because you're trying to get exact answers here. If you were to round it, then you'd be able to put it in the calculator and find the rounded answer. But the exact answer right there would be 7 times the square root of 3. So with that, your y right there. Oh, okay. Yeah, your y would be the 7, or your x would be the, your x would be right there, because it says x right there. So x equals 7 times the square root of 3. Your y would be 7. So with that, let's see if the answers are correct. And the answers are correct, because x equals 7 right there, and then y equals 7 square root of 3, like it is right there. So you both the answers are correct. So this is how you find, or with the special relationships of triangles, this is how you find the relationship between the ratios that exist among the lengths of the triangles because of their angles. So thank you, and I hope you enjoyed this and understood it. Yeah, bye.